In this video, there are two goals. The first goal is, given a density problem, solve for either density, mass, or volume. And our second goal is to determine if substances will float or sink, given their densities. Okay, here we go. Oh, this is supposed to be highlighted right here. Density is the mass per unit volume of a substance. So it depends on both of these things, mass and volume. And it tells us the degree of compactness of a substance. Here's the actual equation right here. D equals m over v. I believe we did go over a way that you might be able to remember it, like this heart right here. Cross it right there. See how there's mass on top and volume on the bottom? Well, that's density. Now, the m represents mass, and that's usually in grams. And the V represents volume, and that can either be in milliliters or centimeters cubed, either ones. So that means that the density unit can either be grams per milliliters or grams per centimeters cubed, since it's mass divided by volume, right? Okay. There's a thing on the right that you may recognize this if you've ever been taught density. I'll speak about this in just a second. Now, if a problem asks to solve for mass or for volume, you can rearrange the equation. So sometimes a problem may ask, hey, given this given this mass and given this volume, what's the density of the substance? And obviously you just take mass and divide it by volume, right? Sometimes you're going to be given a problem where you're going to be given volume and density, and you'll be asked to solve for mass. Or even you'll be given density and mass, and you'll be asked to solve for volume. How do you solve those problems? Well, you would rearrange the equation. Now, this is just a proof for it. You don't really need to remember how to do this, but mathematically, it always is good to understand where these things come from, right? So this is the proof for solving for mass, if a question is asking you to solve for mass. So I'm going to start with the original density equation. This is just by definition what density is, right? Okay, sorry about that. I don't know what's going on. Okay, density is equal to mass divided by volume. Okay, that's the original equation. Now, if you're trying to solve for mass, that means you want mass to be by itself. Okay, in order to get mass by itself, I'm taking a look at volume right now. You see how mass is being divided by volume? You want to do the opposite of divide. You want to do multiply by volume. That will get rid of the volume. But this is an equality. And hopefully you remember that if you multiply by volume on the right side, you have to multiply by volume on the left side. Right? Something like that. Now, on the right side, you may know this. Hey, what cancels out? Volume and volume. What's left? Mass. So, mass is equal to density times volume, or mass is equal to volume times density. Okay? So, I can rewrite that now. Just drawing an arrow. Mass is equal to density times volume. And then if you're given a problem where you're given density and you're given volume and you're asked to solve for mass, you just use this equation and you plug in density and you plug in volume and you just multiply them. Okay, what about for volume? What if you're trying to solve a problem where it's asking for volume and you're given density and mass? Okay, here's the proof for the equation for volume. I'm actually going to start with the one that I just proved. Mass is density times volume. Okay, what if we're trying to solve for volume now? This one right here. Well, you know how we isolated mass in the previous one? We're going to do the same thing here. We're going to isolate volume. We're going to make it by itself. Right now it's not by itself. It's being multiplied by density. So to get rid of density, I do the opposite of multiply. That's divide, right? I divide by density. But if I do on the right side, hey, I have to do on the left side because this is an equality after all, right? And on the right side, look, I have density over density. What happens to them? They cancel out. Now I'm left volume by itself, aren't I? And if I'm looking at this, hey, it says volume is equal to mass divided by density. Volume is equal to mass divided by density. So I'm going to write an arrow. I'm going to say, hey, volume is equal to mass divided by density. Okay, I just realized I erased the canceling out part. I'm going to put this back in. Those were canceled out. Okay, so there's that equation. So if you're given a problem, and again, it's asking to solve for volume, and you are given mass and density, you would plug it into this equation. You plug mass in, and you plug density on the bottom, and you divide mass by density, and then you'd have volume. So, okay, now I'm going to go back to this triangle right here. What was this triangle for? It's just an easy way to remember the three equations, just by drawing a triangle. Now, if you have this triangle, you do have to remember the locations of D, M, and V. D has to be on the very left. Okay, you start, writing from left to right. D has to be on the very left. M has to be on top, and V has to be on bottom. That's just how it works, okay? Those are where the locations are. Now, if you covered, or before you cover it, if you're asked to solve for density, right? If you're asked to solve for density, you would cover the density part. What is density? Well, density is mass divided by volume. That's this one right here. See that? What if you're asked to solve for mass? You'd cover the mass part. Mass is, notice how they're not over each other, they're right next to each other. Density times volume. That's this one. Mass is equal to density times volume. Okay, what if you're asked to solve for volume? You'd cover volume. What do you have left? I have mass over density. Volume equals mass over density, right? So using this triangle, you can easily remember the three equations. But you do need to remember, hey, density belongs on the left, mass is on top, and volume is on the bottom, and it does make this like shape right here. That's an easy way to remember. Okay, you do need to know all three equations. Okay, here's an example of actual density calculation. And this right here, I'm just going to go about it. I'm not going to read it right now. Example, a sample of aluminum has a length, width, and height of 2.5 centimeters each. Okay, what is its density if the aluminum has a mass of 42.2 grams? Okay, now what is this problem asking us to solve for? Actually, that's number one right there. What are we trying to solve for? What is density? Oh, we're trying to solve for density. We're trying to solve for density. So what equation could we use to solve this problem? Right? Well, the equation, remember, you can use a triangle if you want. We're trying to solve for density, right? Mass over volume. Okay. Density is equal to mass over volume. Okay. Well, do we have mass? Can we figure out its mass? Yeah, its mass is right here, 42.2 grams. We're just going to plug that in on top. Do we have volume, though? No, we have length, width, and height. But if you remember, hey, if you have length, width, and height, you can actually get the volume. Remember, length times width times height is equal to volume. Okay, now look at this cube right here, because we do have a cube. They're all 2.5 centimeters every side, right? If we have a length, a height, and a width, and all of them are 2.5 centimeters, right? Length times width times height, that gives you volume. So I'm just going to write 2.5 centimeters times 2.5 centimeters times 2.5 centimeters. This is just scratch work. Equals, what's our volume? Let me pull out my calculator. 15.625. 15.625. And this is going to be centimeters cubed. Remember, you're multiplying centimeters times centimeters times centimeters. So it's centimeters cubed. Hey, that's a volume. Excellent. So that means we can take this volume and just plug it in to the equation, right? We have both mass, we have volume. We can solve this equation now. I'm going to write density is equal to 42.2 grams divided by, what's our volume? 15.625 centimeters cubed. Right, that's a unit of volume. Okay, what do we get for this? Pulling out my calculator, we are dividing here. 42.2 divided by 15.6625 equals 2.7008. You just need to give me like 2 decimal places. So I'm going to write 2.70. 2.70. And what's my unit here? Notice that my units don't cancel out. They do not cancel out. So that means they stay in my answer. Grams per centimeters cubed, right? Grams is on top, centimeters cubed is on the bottom. So that is a unit of volume, right? So that's my answer. Cool. Okay. This is a check for understanding. See if you can try to do this one. Pause the video. I'm going to go over the answer right now. What is the volume of a sample of liquid mercury that has a mass of 76.2 grams, given that its density is 13.6 grams per milliliters? Okay, what am I trying to solve for? Volume. What's the equation for volume? Let me draw this little thingy right now. dmv, covering the v part, right? Volume is equal to mass over density. Okay, volume is equal to mass over density. Great. Do I have mass? Do I have density? Oh, I do have mass. I do have density. Great. All I do is plug this in and then divide, right? Simple as that. Volume is equal to, now the mass is 76.2 grams, and dividing by, the density is 13.6 grams per milliliter. Wait, what's going on here? Why does the unit look so funky? Well, I can tell you here that there's something that's going to cancel out. It's grams and grams. And mathematically, if I have a 1 over milliliter on the bottom, it actually goes back to the top. If you want me to explain why in class, make sure to ask me why. But this is going to end up being just milliliters. And that's a unit of volume. Oh, great, it works out. Okay, cool. Okay, so I write out my equal sign and I plug this in a calculator. 76.2 divided by 13.6 equals, oh, there we go, 5.60. And the unit, again, is the only one left is milliliters. There it is. That's how much mercury there was if I have this much mercury, right? That's how many. Wow, this thing is really dense. 76.2 grams and it's only 5.6 milliliters. That's not a lot of milliliters. Okay, let's try another one. I believe this is the last one that we're going to try. Your lab group is trying to get the mass of a piece of gold. Okay, but you don't have a scale. Whoa, how are you going to get the mass? However, your teammate looked up the density of gold online and found it to be 19.3 grams per milliliter. Okay. You also have a graduated cylinder to measure the volume of the piece of gold. What is the mass of this piece of gold? Okay, this seems like a density problem already because literally we have density here. But in this problem, what are we trying to solve for? Well, we're asked to solve for mass. So let me see. Let me do this triangle again. Triangle up here. Density, mass, volume. We're trying to solve for mass this time. I'm covering the mass part. Mass is equal to density. Oh, and since it's next to it, it's times. Density times volume. Mass is equal to density times volume. Do I have density and volume? Let's see, let me look. Do I have density and volume? Yes, I do. I have density. Do I have volume? Oh, that's probably this information right here. You also have a graduated cylinder to measure the volume of this piece of gold. Okay, I guess we gotta figure out the volume of this piece of gold. Now it's starting at right here, right? I'm going to say that's like 15, 16, 17, and I'm going to have to estimate here. This is 17 point, maybe 2? 17.2 milliliters. And it's going to, let's see, 15, 16, 17, 18, 19 point, what? 19 point, it looks like 8 milliliters. Okay, is that it? 19.8, yeah, okay. Now the reason the water went up is because of the gold, right? Water displacement. So to find the mass of this piece of gold, you would subtract these two values. You would take 19.8 milliliters, and you would subtract 17.2 milliliters. And I'm just going to work out the math right here. It looks like it's going to be 2.6 milliliters. You can confirm on a calculator if you want. But again, this is the volume of the piece of gold. Okay. Oh! We can just plug that into the equation. We have density, we can plug it in. We have volume, we can plug that in, right? So I'm just going to write down right now that the volume is 2.6 milliliters. Volume, right? Cool. And I'm just going to plug that in here. I'm going to plug both of them. Let's do it. Density is 19.3 grams per milliliter. I'm going to multiply by 2.6 milliliters. Hey, look at the units. Let's dimensionally analyze these. What crosses out? Does anything cross out? Oh, this milliliter's on top, this milliliter's on the bottom. Yeah, they cross out. What? What are we left with? Grams. Does that make sense? Well, we are solving for mass, right? Oh, it does make sense. Grams is a unit of mass. Beautiful. Okay, so we're just going to type this in a calculator now. We're multiplying 19.3 by 2.6. Gives me 50.18. That kind of makes sense, right? We should expect it to be a little bit bigger. 50.18. Oh, that's the mass of the gold. Notice how, hey, we didn't even need a scale. All we needed to know was, if we know its volume and its density, we can figure out mass, right? If we know the volume and density, we can figure out the mass. Isn't that neat? Okay. This is the second objective. This one's real simple. Floating or sinking? Well, you may already know this. Substances that are more dense, it will sink. But there's a big misconception. Usually students think, hey, this thing is sinking because it's heavy. Well, sorta, but more accurate statement would be it's sinking because it's more dense. Sinking or floating does not depend on mass. If you could imagine this huge oil rig right here, right? This huge thing. It is super heavy. How is it staying right there? It's because it's less dense than the water. Right? It's super heavy. You'd expect it to sink, but it doesn't. And the reason is because it's less dense than the water. Right? It's floating. Okay, here's an example. Example question. If a company spilled petroleum oil, which has a density of 0.8 grams per milliliter, into the seawater, which has a density of 1.03 grams per milliliter, explain which substance will float. It does say explain, so don't just tell me and then leave it at that. Explain why. So, okay. Well, we know that substances that are more dense will sink. So, seawater is more dense. So it would sink. Therefore, sorry my writing it looks kind of like chicken scratch right here. Therefore, petroleum oil which is less dense will float. Something like that, right? Maybe you didn't have to word it with as many words as I did, but again, the seawater is more dense. If it was mixed with petroleum oil and seawater is more dense, it would sink below the oil. The oil is less dense, so it would float above the seawater, and that's actually what happens. That's actually what happens when oil spills in the ocean. It just starts floating. And it's kind of neat because you can clean up the oil a little bit easier that way since it's floating. Okay, this is just a check for understanding. Assuming these substances will not blend together with water, will they float or sink in water? So just think about this, all of these stuff. We know the densities, right? It says grams per centimeters cubed on this one and grams per milliliters on this one. But just note that centimeters cubed, 1 centimeter cubed is equal to 1 milliliter, so these density values are basically the same between these two lists. So, a cork, will that float or will it sink in water? Here's the density of water. Butter, will it float or sink? Pause the video, think about it. Here are the answers. A cork is less dense than water, so that will float. Butter is less dense than water, it will float. Ice is less dense than water, it will float. Sucrose, assuming it doesn't blend together with the water, it is more dense, it would sink. Oh, it does, actually. If you try to mix like a bunch of sucrose, which is sugar, in water, like a lot of it, right, it ends up going to the bottom. Bone, 1.85, that's more dense than density of 1 for water. That would sink, right? I hope you understand the idea here. So anything that is above 1 will sink in water, and anything that's below 1 will float, like gasoline. Gasoline will float. Ethyl alcohol will float, assuming it doesn't mix. Kerosene will float. Turpentine will float. Anything less than the density of water will float in water. Seawater, assuming they don't mix, right? Seawater would sink compared to just regular water. Milk, assuming it doesn't mix, milk would sink. But, you know, in reality it does. Mercury. Mercury is super dense. That one would sink in water. Okay. Alright. Hope you found this video helpful.